Hello, this is Dr. Anyashola Ogundele, Astronautics for Exploit. Prospective in space manufacturing products. The focus points of my presentation are as follows: rationales behind space products and prospective in space product manufacturing. Space industry expected to generate annual global space economy of more than $1.25 trillion by the year 2030 is being reshaped by the human ingenuity, advanced innovations, new space players, desire to unlock untapped space resources, to engage in space tourism, and to perform off-Earth manufacturing of products otherwise difficult to manufacture on the Earth or affected by the effect of gravity for the benefit of humankind. Space infrastructure, backbone of some of the services used on the Earth, such as communications, GPS, Earth observation, financial services, air transport, maritime, and a host of others, must be invested into in order to be able to exploit the full potential of the space economy. Presently, government space agencies and new space companies' attentions are shifting to the provision of in-space services such as in-orbit manufacturing of products to be used in space instead of transporting them from the Earth, in-orbit refueling and repair, and orbital transportation services. Manufacture of products in space is becoming feasible based on the renewed interest in engaging in deep space exploration and to reduce the cost of transporting them from the Earth. In the future, some of the prospective products anticipated to be manufactured in large quantities in space are high-quality fiber optics, space structure, space infrastructure, protein crystals, semiconductor, recycle and space tools, human organs growth in space, and space food. A research endeavor is ongoing at the International Space Station to study how stem cells in zero gravity can help to grow human organs. Space-printed organs will help to reduce organ transplant waitlist and organ rejection on the Earth due to effect of gravity. Manufacturing of semiconductors in space will be effective as the contamination by the air particles will be eliminated. The newly developed monoclonal antibodies, drugs, engineered proteins designed to target attacking cells such as inflammation and cancer is being researched on at the International Space Station. One of the aims is to crystallize MABs in the microgravity to obtain high concentration and high quality mixtures that can be administered to the patients in an effective manner. Rationales behind space products. Some of the rationales behind manufacturing products to be used in space are highlighted. The cost of transporting products such as food, tools, medicine, and a host of others for the use in outer space is very high, and as a result of this, efforts are ongoing to manufacture such products in space rather than manufacturing them on the Earth. Ability to manufacture products in space will make the products available at all times without the need to rely on supply from the Earth. This picture shows illustration of spaceship preparing to depart a low Earth orbit space dock. For the space economy to exploit its full potential, it will require a well-established space infrastructure, such as orbital transportation services, manufacturing, and others. By putting in place various innovative services, product manufacturing in space will become a reality. This picture shows Voyager space station with infrastructure built in orbit around the Earth, which is expected to be operational in the year 2027. Prospective in space product manufacturing. Some of the products that are prospect for manufacturing in orbit are highlighted as follows. Space high quality fiber optics product, space structure product, space infrastructure product, space protein crystals product, space semiconductor product, recycle and space tools product, human organs growth in space, and space food. Space high quality fiber optics product. Siblan, which refers to zirconium, barium, lanthanum, sodium, and aluminium, is a promising fiber optic material for space manufacturing. High fidelity optical fiber. In 2016, plans to begin the commercial manufacturing of high fidelity optical Siblan fibers in space via its made-in-space fiber facility were announced by NASA. This picture shows made-in-space design of a self-assembling satellite as part of its orbital manufacturing business. It also built a machine to make fiber optic cable on board the International Space Station. Siblan significant advantages. So, manufacturing a high-fidelity fiber optic product has a lot of significant advantages, such as in space, fiber optics can transmit a broader spectrum. Several lasers of different colors could use the same fiber at the same time. Fiber optics absorb less light in space, and therefore fewer signal boosters called repeaters are needed in long-distance cables. This picture shows made-in-space produced Siblan optical fiber in orbit using the machine. The company plans to launch a second bigger Siblan manufacturing facility to the International Space Station. In collaboration with Thorlabs Incorporation, made-in-space conducted the optical fiber production in microgravity investigation on the ISS from September 2017 to 2018 in order to set the stage for large-scale manufacture of high-quality fiber optics in orbit. Reduced flaws. When developed in microgravity, fiber optics flaws are minimized, and the performance of the resulting fiber can be orders of magnitude above that of fiber created on Earth. This picture shows space facility for orbital remote manufacturing. Space structure product is another product that is being planned to be manufactured in space. Research and development activities on manufacturing large structures in space, like space stations and space telescopes, and using 3D printing or additive manufacturing are presently ongoing. Development of large structures in space requires advanced technology, which will enable easy movement of structural materials and assembly parts from one part of the space or one orbit, planet, or moon to the other for easy assemblage. This picture shows made-in-space Astronaut spacecraft. Space structures products. On Earth, a lot of manufacturing processes need expensive equipment and reinforced facilities for manufacturing products. Using fewer resources, products can be safely manufactured in space. Spider Fab. Thetis Unlimited is developing a revolutionary suite of technologies, refers to as Spider Fab, to enable on-orbit fabrication of large spacecraft components such as antennas, solar panels, trusses, and other multifunctional structures. This picture shows a printed product float in front of the AMF on the International Space Station. Made-in-space Astronaut. The proposed concept involves using additive manufacturing, which is reversed as 3D printing and robotic assembly capabilities to demonstrate how large structures can be built in space. Astronaut is a Redwire enterprise solution for in-space manufacturing needs, enabling the next generation of large-scale and off-world manufacturing. It is a customizable suite of manufacturing and assembly technology which can be integrated into free-flying satellites. This picture shows a keynote concept. There are various notable proposed space structures, such as space orbital ring. An orbital ring is a concept of an artificial ring placed around the Earth and set rotating at such a rate that the apparent centrifugal force is large enough to counteract the force of gravity. The structure is intended to be used as a space station or as a planetary vehicle for very high-speed transportation or space launch. This picture shows orbital ring concept. Another proposed space structure is space elevator. A space elevator is a proposed type of planet-to-space transportation system. The main component will be a cable, also called a tether, anchored to the surface and extended into space. The design will permit vehicles to travel up the cable from a planetary surface, such as the Earth, directly into orbit without the need for use of large rockets. This picture shows space elevator with space station. Space infrastructure is another product that is being envisaged to be produced in space. Space infrastructure is an invisible backbone for services used by people all over the world. Like terrestrial infrastructure, space infrastructure is increasingly relied upon for convenience, services, and national security. This picture shows Project Icarus orbital construction ring prototype design, which shows resupply from the Skylon single stage to orbit spacecraft under development by reaction engines. Essential systems such as communications, air transport, maritime trade, financial services, GPS, weather monitoring, and defense, all of these activities rely heavily on space infrastructure, including satellites, ground stations, and data links. Illustration of space infrastructure is shown in this picture. On-orbit servicing, assembling and manufacturing are revolutionizing space operations and exploration. Some companies are performing research and development and investing in the development of space infrastructure. Demonstration of Orion spacecraft is shown in this picture. Space infrastructure development. Marshall Company is developing space infrastructure technologies, such as robotics technologies, which will help to extend mission lives, enable the use of larger components, and advance exploration in space for more sustained manned and unmanned missions that transform what we can do and learn. Illustration of on-orbit servicing, assembling and manufacturing spacecraft designed to render for, with, grasp, refuel, and relocate a satellite to extend its life is demonstrated in this picture. Space protein crystals products is another product that is being envisaged to be produced in space after technologies might have been advanced. Recently, pharmaceutical companies have developed a new drug reversed to as monoclonal antibodies that compel human body immune system to target specific attacking cells and bacteria. The MAB drugs engineer proteins that bind themselves to substances that cause disease. They can be used to treat inflammation and cancer. An example of protein crystals grown in microgravity is shown in this picture. A crystal of bovine insulin grown in space is shown in the left, and the one grown on Earth is shown in the right. In order to be effective, large quantities of MABs are needed to be delivered intravenously over several hours. Presently, research is ongoing at the International Space Station towards crystallizing MABs in microgravity so as to get high concentration and high quality mixtures that can be given to patients more efficiently. This picture shows difference between protein crystals grown on the ground versus the one grown in microgravity. Space semiconductor product is another product that is being planned to be manufactured in space. Semiconductors are essential for most electrical circuits and components. The semiconducting material gallium arsenide was one of the first materials made in space at the reshaped facility back in the 1990s. On Earth, creating thin film semiconductors such as gallium arsenide can be challenging as the material is easily contaminated by particles in the air, but semiconductors can be easily manufactured in the ultra-pure vacuum of space. The worksheet facility deployed by the Space Shuttle's robotic arm is shown in this picture. Recycle and Space Tools product. Made in Space Company is working with NASA on the creation of specialist tools and replacement parts in orbit. At NASA's additive manufacturing facility on the International Space Station, they have worked with Made in Space and other partners to create an advanced 3D printing facility that can work in microgravity. This picture shows Refabricator, a recycler and 3D printer launched to the International Space Station for technology demonstration. Recycle and Space Tools created by AMF in space are as follows. The first commercial part ever produced in space, a cobalt wrench. The first medical supply item ever printed in orbit, a customized finger splint. The first piece of art ever 3D printed in space, and the first item printed in space from polyethylamide polycarbonate, a strong heat-resistant aerospace-grade material. This picture shows AMF's cobalt wrench, the first commercial part ever printed in space. Human organs growth in space is another area of interest to researchers, which they are working on in order to find a way of growing human organs in space. Traditional organ transplants can often only be temporary fixes or might fail entirely, endangering the patient further. But organs grown from cells extracted and cultured from an individual have a far higher chance of being accepted by the body. On Earth, gravity can make it harder for the organs to grow properly. This picture shows experiments being conducted on the International Space Station to show organs could be printed at low gravity environment. On Earth, tissues and cellular structures can collapse under their own weight, and capillaries can fail to propagate blood and other liquids. Biofabrication facility. Textured Company has developed a biofabrication facility that uses 3D printing techniques to grow biological patches for earth repairs. This picture shows Textured Biofabrication Facility. The facility was launched into International Space Station in 2019 in order to test the concept of developing new organ material from a patient's own cellular material. There is possibility that one day it will be possible to send a patient's cells to a space station, 3D print a new organ, and get it sent back to Earth to be implanted in the patient instead of waiting for a donor. This picture shows demonstration of astronauts' use of biofabrication facility on board the International Space Station. Space food is another area of research that researchers are working on so that foods can be produced in space for the astronauts' use and also for the intending mission into deep space. Everything transported on missions or to space stations is preserved in a form that can affect the taste, diversity, and texture of the food. BS Chief 3D system is designed to 3D print food items in space, enabling astronauts to enjoy their favorite foods freshly prepared for them in orbit. This picture shows red LED lights illuminating potato plants in a NASA study on growing food in space. As various companies and agencies are gearing up for manned missions to Moon, Mars and beyond, solutions for creating different kinds of food in space are being researched on and invested into. This picture shows assortment of foods served aboard the International Space Station. For more information, contact Astronautics for Exploit. You've been watching and listening to Prospective in Space Manufacturing Products, presented by Dr. Ayansola Ogundele, Astronautics for Exploit. Thank you.